second keynote speaker for the day is Professor Antonio Moreno. So Antonio is a linguistics professor and the director of the Computational Linguistics Lab at the University Autonomous of Madrid. Antonio also is the director of the UAM IIC, the chair of computing linguistics, and he's a former Fulbright postdoc scholar at the Computer Science Department in New York University, and a former DAT scholar at Augsburg University. All right, so Antonio today is going to talk about annotating discourse markers and key financial terms in Spanish with transformers. Antonio, whenever you're ready.
Okay, thank you. I'm going to put my clock. Okay. Okay, thank you. The title of this talk is very computational linguistics, annotating discourse markers and financial terms with transformers. But actually, the title I would like to use is this one. What is so difficult to classify winners and losers from the letter to the shareholders, both for human expert and artificial intelligence systems? But it is so long title, so I use the other one. Okay. The starting point of this research question is an evidence. Thanks to the accounting data, we know the reality of the companies in the previous year, but the financial narrative masks the cases with bad results. And we have the evidence that the style and the tone of the letter to the shareholders are very similar in all the companies analyzed. So we want to study this particular thing, this particular research question, and is what we are talking about this time. Okay, this is the more or less the outline. Okay, we'll start with some previous evidence, and then we discuss computational issues and linguistic issues, and then we talk about our experiments with discourse markers and financial terms. Well, we compiled probably the first financial dataset in Spanish as a part of the FinTest project. This dataset is based on the annual reports, the Spanish annual reports, and we extracted 100 small documents, small tests on around 500,000 words. And this corpus is the letter to the shareholders. These documents are prepared for processing with NLP pipelines like Tagger, Parser, and entity recognition. And we are used this corpus for both for processing and for linguistic analysis of the financial domain. So this is probably the first financial dataset, I'm for sure, for Spanish, for LMP. And if you want to know more about that, you can go to this reference. The first thing we did with this dataset of letter to the shareholder was to conduct an experiment on sentiment analysis. And it was presented at the second financial narrative processing at Turku in 1999. Here, our research question was, how do the company's results affect to the communication strategy? Our hypothesis, based on previous studies, is that it was a clear tendency towards a positive tone. We create a golden standard with a selection of sentences, 100% of the data set, And from the investor perspective, we have only three possible tags: neutral, sentences that are that don't have any judgment; positive, which is positive messages that are based on actual economic facts; and the negative, which are bad news or positive expression that mask bad results. I'd insist that our approach, our perspective was the investor side. We have a financial expert, Dr. Anna Hisberg, who know all these tricks that the communicators use for expressing negative results or bad results then inside a narrative. The annotators were linguists, myself and another linguist, and we agree more on the sentence for the profitable companies than on the sentence of the loss-making companies. For us, it was very difficult analyzing sentiment in loss-making companies. So we need the approval of our financial expert, Anna Hisberg, to obtain a reliable golden standard to check sentiment analysis tools. So we, in this experiment, we detect the difficulty for human linguists with no previous knowledge on financial terms, they properly classify the loss-making companies. You have here on the screen comparing sentiment distribution in two gold standards. In the left side, you have a gold standard for Twitter, and in the right side, you have the gold standard we develop. You see, the distribution of neutral, positive, and negatives are very different in both domains. In Twitter, you have mainly a half of the tweets negative and the other positives. But if you go to the financial narrative, in our gold standard, you see that the 70% of the sentence are positive. So this bias to the positive information is very clear, as you can distinguish in this sentiment distribution. So we use three opinion mining systems. The one from Microsoft, the one for IBM, and our own system. And the two previous ones, Microsoft and IBM, use machine learning techniques, and our system use lexicon rules and rule-based, without financial domain specific polarity lexicon. You can see here to the left the gold standard, and you can also observe the performance of the three systems. It's very interesting to notice that the Azure has a clear tendency to the positive polarity. And in fact, they got better results than the other one. For instance, IBM has a clear tendency to the neutral, and our lexicon-based system has a distribution more or less between neutral and positive. So the results were not very good, between 0.58 and 48 and 0.54. So after this experiment, we wanted to check it human experts. And in February 2019, we conducted a survey with almost 50 students of the Master in Financial Accounting at my university, divided in pairs. Each of the 24 pairs analyzed a different set of 5 letters to the shareholders. The survey was conducted in the classroom on the printed documents and for 1 hour. They could not use any external reference, only the test of the letter. Only one question they have to solve. With the information in the test, you must decide whether the company made a profit or a loss in the previous year. It was remarkable that no master student in finance got the complete 5 correct. So we can assume that these are experts. They are not linguists, they are experts in financial narrative. So this is a proof, again, that something is difficult for the humans and also for the artificial intelligence systems. So now I will address some computational issues in order to understand the problem. Elhadz, myself, and Jimenez Millán, we testing different machine learning classifiers. We start from the objective data of the audited accounting results. We know exactly where are the companies which have benefits and the loss-making companies. We don't need a judge or a prover. You already know from the accounting results. Detecting automatically the positive or negative tone was not satisfactory with these machine learning classifiers. So, can the machine learning method be more accurate in a binary classification? We only have to decide gain and loss, the only 2 classes. But the main problem was the imbalance between the 2 classes. We have 85% in the gain class and 15% in the loss class. And the second problem for the machine learning techniques is we don't have sufficient data. We don't have sufficient data. So the first thing was to think on upsampling. Is upsampling a solution? We split the dataset into training, validation, testing, and duplicate only the samples of the minority class in the training set. We multiply the, I think around 42 by 6, and we remain the validation and test the same. Okay, so now the data set is more or less balanced between gain and loss. With this upsampling, we use classical and deep learning without word embeddings. And the best results was the obtained by the SVM and logistic regression. Perfect. The use of deep learning with embeddings, without embedding, sorry, the best model, the best outcome was only 0.94. So it was shocking that the classical machine learning has outperformed neural models, both with an upsampling. The next experiment was to use deep learning with word embeddings, with pre-trained embeddings. We compare 2 approaches. Without the upsampling, we use the real sampling, 45 against 15. We use transformers and we spacing. For transforming, we use the Beto, which is developed by the Chilean University, And the spacing with the embeddings, we use the pre-trained model Moreno. And we got this very close results, better with the transformer developed by the Chilean university, but they don't get the results that we obtain with the unsampling. You see? The best result with deep learning. This was very perplexing conclusions, but the best results in our experiments are achieved with classical models, of course with unsampling. Then deep learning without embeddings, and finally a state-of-the-art model, but without the tricky unsampling. So these experiments were very, as I said, perplexing for us, and we explain another things we are implementing recently in our lab. But before to explain that, I want to address some linguistic issues in order to understand our new approach. From the point of view, from a linguistic point of view, the metaphor in financial narratives is very well known. We study, Vargas and me, study in our data set in Spanish. The metaphors of war and health are the most widely used by the president when they deliver the narrative to the shareholders, because their persuasive function aim both promoting a positive image of the company and also the manipulation of the previous year poor performance in the case of the companies with bad results. The typical metaphors are: investors are invited to enlist in a mighty army, that is the company. Or investors must rely on the doctor for the patient's full and speedy recovery, understanding that the doctor is the management team and the patient is the lost company. So investors are supposed to will earn dividends in the next financial year if they trust the doctor. They are the typical metaphors in the letter to the shareholders. Other common metaphors are about constructions, journey, and the machine. Now, we also focus on discourse markers in the financial discourse. Letters to the shareholder are examples of an argumentative test for persuasive purpose. The manager intends to convince investors to continue investing in the company. Thus, we use the discourse markers. It's essential to understand argumentative strategy. Some conclusions from our study are the following. First of all, discourse markers are only 1% of the corpus, or the total tokens of the corpus, only 1%. But they are twice as much as in the national Spanish corpus. So the discourse marker are more used in this context of argumentation for financial narrative. The most frequent discourse markers in this domain are the so-called connectors, like furthermore, as well as, they are translation of the current Spanish words. And also what we call information structurers. Finally, on the other hand, in the function of these discourse markers, both connector and information structurers, is to allow the progress of the discourse thematically. So they are very, very frequent in this domain. So personally, we find a word, a discourse marker, adicionalmente, which is a call from the English in addition, what is not considered as a discourse marker in the reference list of discourse markers for Spanish. So when you use this list, there is no word as adicionalmente. This, our discovery, we thought that this discourse marker is specialized and characteristic of financial discourse. So you can get this discourse as a predictor that you are working on probably in a financial discourse or financial narrative. Because this adicionalmente is not in other discourse, for instance, oral discourse. Here we have a distinction between the discourse markers used by the profitable companies and the discourse marker preferred by the loss-making companies. In the first case, we use what we call additive discourse marker, likewise, also, and also the argumentative reinforcement, like especially, in particular. On the other hand, the loss-making companies prefer use what we call counter-argumentative discourse marker, in spite of, however, and also reformulation, in short. So we were wanting to use these findings, and we're trying to do some experiment with discourse markers. We developed a discourse marker tagger. We only have two classes. This is comparable to an innate entity tagger. We have discourse markers and no discourse marker. They only two classes in this annotation system. What is a discourse marker? Any unit with this function has been annotated. Only those that function as a discourse marker can be annotated if in the case of the ambiguous word. For instance, but, pero, not always is in a discourse marker. The discourse markers have been annotated by hand without pre-annotation list. A very detailed annotation guide has been elaborated for each discourse marker, and we have over 200 discourse markers. And we write down this detailed annotation to distinguish context. The frame of the annotation is the whole text, not only the sentences, the whole document. And the no discourse markers are the remaining token, which is 99% of the document, and they have not been annotated. The text only have annotation for the discourse markers. The experiment has three phases. We annotated, we used Ocano, which is similar to Prodigy, and we get, this is wrong, this is 387, no 487, it's 400 tests. We take it, and we develop the annotation guide and the training of the linguistic annotator through the shared annotation between both of them. We used 100 tests. In the second phase, each annotator proceed with a blind annotation in order to get the inter-annotator agreement. Only 4 tests. And finally, with this, we train a tagger, automatic tagger. With this system, we automatically pre-annotate the rest of the test, and then the annotator, the human annotator, do the revision by hand. In total, 130 each annotator, human annotator. The preliminary results of our discuss marker tagger is we use this with the 100 tests, only with 100 tests, just to check it if the model can be get any results, and we get very good results. It's important to note almost 99, including the tags for discuss marker and non-discuss markers. The model memorizes the training data very well. We don't use the typical evaluation of train, development, and test. We use everything for training and to do the evaluation. The system was very well performing with the discuss markers memorizing. But in the last phase, when we have the 400 tests annotated and we have the gold standard with approval by the human annotators, we conducted the proper evaluation. The proper evaluation is this one. We use, it was in June, we used the state-of-the-art transformer in Spanish. It's called Roberta, developed by the Barcelona supercomputer and the Spanish National Library. It was in June. And we conducted 10 runs with random selection from the test, the complete letter to the shareholders, with a partition in this case of 80% for the training, 10% for development, and 10% for the test. And after 10 runs, the average was 93, and the standard deviation is only 0.01. So it was not as good as the 0.99, but 93 is very good. It's very good with a limited amount of data. Now we wanted to check it, this same experiment, with the financial terms. We wanted to develop a financial term recognizer using transformers. So first, we divided 4 classes. It's again comparable to an identity recognition. The 4 classes are corporate social responsibility, corporate governance, strategy and management, and accounting and finance. Of course, there is an imbalance, and you will see, between the 4 classes. Again, we use 3 phases of annotation from 10,000 random FNP sentences, extracted from the annual report, not from the letter to the shareholders. We developed the annotation guide and the training of the annotators with 3,000 sentences. And then we use the blind annotation of 1,000 sentences. We stop here. So we have now 4,000, a golden standard of 4,000 sentences annotated with terms in these 4 classes. Again, we conducted a preliminary results only for detecting the ability of memorizing the data, and again we get very good accuracy. You can see here the imbalance between different classes. Contafins and accounting and financial terms, they are most of the total, and are very few of them for social cooperative responsibility. So this imbalance is also very difficult to get addressed. In the micro average, we attain 0.94. But considering we run the 3 sentences and then we pass the evaluation for the 3,000 sentences. So it's only memorization. It's a kind of development. When we conducted the, okay, here. When we conducted the proper evaluation with 4,000 sentences annotated with terms, we again use the Roberta transformer, 10 runs, and with the partition of 80, 10, and 10. The gold standard is composed by over 4,000 sentences. And we get a not very satisfactory figure, only 69 as an F measure. So, in order to give an idea of the comparison of the results, and using for all the tasks the same transformer, the Roberta-based transformer, which is probably the best currently, with different data sets, we have this. If you are conducting sentiment analysis with 3 or 4 levels, we got the worst results. With our FinTER, we are almost like the sentiment analysis with 4 levels. The sentiment binary, you only have sentiment or no sentiment, you get better results. In the task of name entity recognition, with this Roberta base, you get almost 90%. And our discourse marker tagger is over this NER outcome. 0.93, which is very good, the discourse marker. And the best, of course, because it's the most training, is the part of speech. In Spanish, we get 96 with this Roberta base transformer model. Okay, so we can see that with using terms, we are not very well in the position, in the rank, but if we use the discourse markers, we get better results. So, as a conclusion, let me check how much time I have. Okay, I think I'm more or less on time. Let's go to the conclusions. Why is so challenging to identify winner and loser for financial narrative? That's the question. Financial communicators are adept at hiding bad information that can negatively affect the perception of the company's situation. The sentiment analysis and the machine learning classifier tools that we have used have not worked well with large companies, making companies. On the other hand, we know that the linguistic prevarication, understood as the capacity to emit messages that do not coincide with any real situation in the real world, is one of the symbolic properties of the human language. Together with creativity, the linguistic prevarication allows speakers to invent situations that are at least partially untrue. In other words, language is a very powerful tool for lying and telling half-truths, as everybody knows. Our recent research found that narrators, communicators in the letter to the shareholder use very similar linguistic structure to describe very different actual economical situations. To decipher the complexity of the financial narrative, it seems to us that grammatical elements such discourse markers are more informative than lexical elements. Typically, the most frequent nouns and verbs, metaphor, terms from the financial domain. because both communicators and reader focus more on content units. Discourse marker information may give us clues to more unconsciously expressed features and predictors. From a computational point of view, we have obtained better results with discourse markers, as we saw. This result encourages us to continue exploring the argumentative structure of letter to the stakeholders along two lines. First one, the linguistic pattern of the cause-effect relationship and its association with decision-making. On the second, counter-argumentation analysis, which is characteristic of the narratives of poorly performing companies. This is the team that have participated in the Spanish side, in the FinTech project. So we have a team of computer scientists, accounting, translation, and also we have some PhD students. So thanks to all of that for these results and this research. And it's time for you if you want have any question. Thank you for your attention.
That's brilliant. Thanks a lot, Antonio. I really appreciate it. Just gonna mute myself here. Not quite. Okay, so we've got a bit of time for questions. If anyone would like to raise their hand using the emoji button up there, or right away ask the question in the chat box, and I'll read that out loud. Thanks a lot, Antonio. While people make up their thoughts and prepare questions, if any, I do have a question. So is it kind of challenging to work with Spanish financial narratives in compared to the English one? Because you worked on both of them, and I'm just curious to see if there's any difficulties, like specifically in the Spanish financial narratives.
I cannot respond that question because I only do deep analysis of the Spanish narrative. So, but my feeling is probably is the same. I think the grammatical features, the grammatical units are very well known in stilometry that are less conscious. So probably if we focus on grammatical things like discourse markers, where the generator of the test has less control because they're focusing all the time in content words, nouns, verbs, and adjectives. They, as I show you in this conference, we found more differences in the use of discourse markers than in the use of nouns and verbs. Because my feeling is that the communicators copy each other. They take the best of them, for instance, Santander, and then copy the letter. In a sense, it's my feeling. So one of the things I want to try in the next years is to use study this structure, this argumentative structure, and see if they can we can do any simplification of the structure and a kind of translation, a simplification from this complex narrative to a simpler one in order to detect these differences. Because as I show you, it's not only difficult, and you participate in the experiment, Mahmoud, it's not only difficult for the machine learning or for the artificial intelligence systems, but also it's very difficult for the humans. So we need to explore more on that.
Yeah, I mean, I don't know how challenging is that, because I've worked on both of them actually, and I think part of it is the structure of the Spanish data. I found it to be complicated, at least from my knowledge. I'm not an expert in that, and also the barrier, but also the amount of data available. So as we've seen in Yokenstoke, the more data, the more challenging is to find the sign for alpha, for example. And then with the limited kind of reach of data in your case, that make it a bit challenging. Okay. I can see there's a question, I think, in the chat, so I'm trying to read that. So there's a question from Mohammed. He says, do you think the style of writing will affect the results in your analysis? And he gave an example on not good compared to like not too bad.
Right. I think my feeling is that the main strategy is do not use the bad figures. Is the first one. You can see, because we have the accounting data. So when the president writing the letter, they don't use the bad figures. They say, yes, we are very good in selling forever or whatever, but they don't put the real bad figures. That's the first thing. And but I don't know, maybe in other languages they are more clear in providing information. I really confused in how the Spanish narrative is very hard. In fact, I proposed for the next FNP side tax to use the Spanish test and try to other groups if they can be very good and better in classification, because it's very hard for us. I mean, for the computer scientists and also for the human annotators. So the style, I think they copy the style. This is my hypothesis. In fact, I talked to one who was the secretary of one of these presidents, and told me in confidence that they usually copy the best one and then try to a lot of
Sorry, I said there was a lot of talk about text reuse in financial reports.
Yeah, right.
That is actually one of the things that makes comparing style a bit complicated. I'm just going to go with a last question. There's a good comment from Paul. So Paul says, perhaps we need to train the financial readers of the documents to pay more attention to the discourse markers. So final question before we go into the next talk. So the question from Jochen, I think he says, perhaps there could be a different legal situation, so what you can and can't legally do in each country that influence the degree of detail and degree of framing.
I agree.
Yeah,
Sorry. Okay. I know that, for instance, in the United States, things are different. They have this system, and you have to clearly. But in Europe, and especially in Spain, or probably in Portugal or France, there is no fixed structure to do the argumentation. So I think that's the problem. The degree of detail and the framing and the structure and the things that you have to specify are not legally controlled.
Right. Thanks a lot, Antonio, once again, and giving applause from our tiny audience here. Appreciate your time.